Hello, welcome to Lambda Lounge. This is our February 2021 session of Lambda Lounge, and we are doing a 2-week mini season about Lisp. So today we're going to be starting off with Sam Marshall talking about implementing a small dialect of Lisp in Elixir, and next month we're going to have Veit Heller, who's one of the core team for CARP, which we did a talk about recently, and he will be implementing a version of the Brain F *CK programming language, an infamous programming language in CARP itself. So Sam is one of the co-organizers of Lambda Lounge. He's a software developer working for Digital Bridge. I'm going to bring him in now. And so Sam is working on 3D software, 3D graphics software, and he's using functional programming languages, in particular FPTS in TypeScript, to do that. This talk isn't about that, but it's a nice little fun fact. So I'm going to share your screen, Sam, and then pass over to you. And enjoy, everyone.
Sweet. Okay. Yeah, like Hakeem mentioned, I'm a software developer. Work mainly with TypeScript at the moment. But this is about writing your own Lisp-like language in Elixir. As one of the main questions I get when I talk about this is why write my own language? Why would anyone write their own programming language? I'm going to answer that right at the front. So it's definitely fun for some people. That's often reason enough. But I think bigger is that it's like a new set of stuff to think about. It kind of pushes out the boundary of the level of abstraction you're comfortable thinking with, and that is or can be really powerful. So that's kind of like why I was looking into writing my own language, and I'm still a very much a beginner along this path, but I thought I'd share like where I'm up to along the way. If you want to kind of code along, you should be able to. You just need Elixir installed. The link's in the description, I believe. Throughout this, please feel free to ask questions in the live chat freely. I'll try and answer them when they pop up on the screen as we go along. And afterwards, if you've got any kind of bigger questions or you want to talk about this, I'm going to hang out in the voice channel on Discord, which there may be a link to in the live chat, hopefully. Getting started, the target language is one called Lixp. It's a language which I made up. It doesn't really, it's not really got enough definition to be its own language yet, but it's essentially a Lisp. I have put together a document which kind of runs you through what the language can do, specifically in the order that we're going to implement it today. Hopefully that can be shared in the live chat as well. I'm seeing some people pop up on the document, so that's probably a good sign. Or we're in the future.
Yeah, I'm sharing those links there now. So just let me know if there's anything else you want me to pass on.
No worries. I think that's everything for now. And so yeah, that kind of describes the steps we're going to take. About halfway through, there's a interlude where it depends how far we get as to how much of that we'll see. Which like it's basically dependent on how long all this takes. There's quite a lot to get through, and I'll be describing the host language Elixir as we go, because I'm kind of aware that not everyone will be familiar with Elixir. The reason I picked Elixir is because the the algorithm I use for evaluating the programming language relies quite a lot on pattern matching, and Elixir's got quite a nice pattern matching kind of thing going. And I'm interested in Elixir, so that's basically it. If I kind of gloss over a feature, or you don't understand what's going on, again, please ask. Right. It's probably time to get started because we've got a lot to get through. So I'm just going to remove the kind of, remove the kind of test directory I had going on, and start by making a new Mix project. Mix is like the package manager of Elixir. Mix new Lixp, and that should create a bunch of template files. So we're going to start in the mix.exs. This is, if you're familiar with JavaScript, it's like the package.json, or like basically the project kind of definition file. I'm going to go to defp-deps and add a new dependency. So we're going to build effectively, we need to build a parser and an evaluator. We're not going to build a printer. That kind of like left as an exercise to the audience. We're not going to write the parser from scratch. Instead, we're going to use a library which is called Nimble Parsec. That's going to basically, it's a parser combinator library. So that's going to basically let us tell, like declaratively say what we want our parsers to look like, and it'll build them for us. Use this rather unusual syntax. But this is a tuple, this kind of curly braces section. And then you've got an atom, Nimble Parsec, which is the name of the library, and then a string describing the version. In the console, you then need to do mix steps .get, and that should download the package. Cool. So as you can see in the document, the first thing we're going to want to do is parse out and evaluate the number 5. So we're going to start with a parser. That's going to go in lib from the like relative to the root of the project, lib lixp parse.ex. Oh, sorry. That's me typing in Vim commands into the console. You're gonna need to make the Lixp directory inside lib to have that happen. And then we're going to define a module. So in Elixir, modules are effectively named bags of functions. They don't have any structure other than being like a namespace. But they allow you to do things like import other namespaces. What this does in Nimble Parsec's case is pull in just a bunch of stuff, including a load of macros, which are going to make what we need to do easier. We're going to start with a number, as I mentioned. You'll notice that when you input 5, we're going to output 5.0. We're just going to treat all numbers as floats just for simplicity's sake, because it means we can handle all cases far easier. So we're going to start by defining a digit. This is effectively saying to Nimble Parsec, what does a digit look like? So we want an ASCII string, that contains any of the characters between 0 and 9. So that's a range, the little the little dot thing that says from 0 to 9 inclusive. And then it needs to be of minimum length 1. So yeah, that's hopefully fairly self-explanatory. So we could say a number is a digit. Obviously, a number's more than a digit, but just bear with me for demonstration's sake. And then we might say def parsec, which is how we define the parsers themselves. So we def parsec number, and this is really just to demonstrate what it looks like when we parse something. So if you run IEX capital S dash capital S, sorry, mix in the root of the project, you will get a compilation error. Nice. Before number.
These are the joys of live coding, aren't they?
Yeah, it's great. I'm just trying to see where I've got my issue. ASCII string. It's going to be something really obvious, and I'm just missing it. It might genuinely be how I'm doing that. Hang on. Oh, no. Before digit. Import def module. So pass import nimble parsec. Well, I'm stumped. That's a good start. Oh, here we go. No, I'm not stumped. I got it.
Excellent.
I got it. I completely forgot that syntax there. It probably is clearer if I add the parentheses. I was just passing in two things as if they were one thing. That's my fault. Apologies. So yeah, running IEX dash capital S mix basically starts up your application and loads in everything in the project. So I should be able to do Lixp.parse.number, and I should be able to pass in anything that's a number, and it will output. So this is, again, it's a tuple, which is just a fixed kind of collection of things. A common pattern in Elixir is that the first thing returned back is some kind of message. This is okay. If it was a problem, it would be error. That lets you like pivot on using pattern matching on what the return value is. This is what we've parsed. So we've returned the array is like the full program that has been parsed. That for is saying that the input Z4. We've not told it to do anything with it. We've just said pass it straight through. And the third one is what's remaining to pass. That didn't match anything. So for example, if we 4, then you'll see it doesn't know how to pass an empty space as a number because it's not a number. So it will just like leave it all there, which can be passed on to another parser. We don't need to worry too much about that because we're going to kind of like glue them all, a bunch of parsers together. The rest of the arguments, the rest of the response, various things, I think largely to do with context. I think the third to last one is line numbers processed, and I'm not actually sure what the last one is, but we're not going to use them, so it doesn't really matter. So getting rid of that. So we're going to need to pass floating point numbers as well. We're going to really leverage Elixir's underlying numbers and just use those just to make things simpler. So we need to kind of say, well, we might expect a dot because floating point numbers have a dot in them. We can just use the string combinator for that. If you've not used parser combinator libraries before, we're not really going to go into what they are, I'm afraid. Don't think we've got enough time. That's a talk in and of itself. but I'm hoping that the relatively straightforward syntax and like gluing things together makes it okay, at least. If not, ask specific questions, but I might brush over that depending on how hard it is to answer. So we might say that a number is therefore a digit, which is optionally followed by a dot, which is followed by more digits. So just format that out. The reason that we are passing dot through, so I guess first I should say this is a pipeline operator, digit optional 4, say, is equivalent to calling optional digit 4 like that. It passes the thing on the left to the first argument position of the thing on the right. It's just a neat way of kind of chaining a bunch of things together. So the reason that we do this little concat thing inside of the optional is because if there's a dot, then there has to be digits after it. We don't want people just putting 5 dot. That doesn't mean anything to us. We need there to be digits. So we concat the digit parser onto the end of dot, and say like these come as a package. So we then might we're then going to need to like. So hang on, I'll demonstrate. Shouldn't have deleted that parser, but never mind. You can recompile the project just by typing recompile, and it'll kind of pull all the new changes in. So if I typed 4.321, because they're separate parsers, you'll notice that they actually get pulled out into a list. That is not what we want. We want to put in 4.321 and get out the number 4.321. So in order to do that first, we're just going to take the string 4.321 and pass it through to the float.parse function built into Elixir. But we're going to need like a single string first. In order to get that single string, we're first going to reduce. So this is a reducer acting on the list, and then we're going to get this weird syntax here. So what this is saying is, in the enum module, I want you to get the function join, because under the hood the functions are just named with atoms. It's like often used to kind of pass around dynamic dispatch kind of things. And the second argument of join is going to be just empty string. So what that's going to do is it's going to take our list and just join everything up together. And if we kind of recompile and run the same input again, you can see that that's the output. One of the things I like about Elixir, by the way, is that the kind of interactive experience is really nice. You can do a lot of introspection from the interactive console from the REPL, and that kind of massively helps when you're doing this kind of thing for the first time, especially, and it helps at this time now. So we need to basically map that through and parse to parse it. We need to pass it into float.parse, which then returns a tuple of the kind of similar to the output we're getting from this parser. It's a tuple where the first element is the number it's parsed, and the second output is the everything else that it didn't pass. So we're going to write a little helper function, parse float. It's going to take a string. Elixir is dynamically typed, so I've called it string, but it doesn't actually know. Just in case that's confusing, we're going to do a string pass to float.parse, and then we're going to pipe that through to lm0. That's going to take the 0th element of the tuple and just return it. Should point out that what we've got here are us calling combinators, so they're actually outputting functions. So digit and dot are functions, but their functions returned from other functions. Whereas here we are actually defining a proper function. The last expression is the return value always in Elixir. So the return value will be whatever lm0 spits out after float passes done its job, which should be the number. So in order to call that, we're just going to map parse float. And again, because of how nimble parsec works, you can't pass in the function directly. You have to pass in the name of the function. The reason being is nimble parsec works using macros, and it actually like generates code afterwards. So it's being run at compile time, not at runtime, and so like you can't pass functions around at compile time. It's just like a weird little thing about how nimble parsec works. You kind of get used to it pretty quickly. And there we go. We're seeing 4.321. So what we want to be able to do is to type Lisp.eval 5, I think is the first input, and have it work. Obviously, we don't, and have it output 5. We don't have Lisp.eval. So that's going to be next. So in lib.lixp.ex, we should have like this kind of default implementation output by mix. I'm just going to delete it. And in its place, we're going to build our evaluator. When I've run this with friends from work, they've been horrified that we've been writing the eval function, which everyone gets told not to use. But of course, like a language does need an eval function somewhere down the stack. Otherwise, you can't evaluate anything. Yeah, we're writing that eval function. So as you might imagine, the first thing we want to be able to do is parse. Hang on, I will just add a little convenience thing into parse at the end. We're going to change this to be program. So we're going to say, I am parsing a program. That's just so we don't have to change this later when we make it work properly. So Lixp parse program, that's our program. And we're going to do pattern matching in order to get the value out. So as we see over here, this is the value we return, and our parse program is the second parameter. In this case, we're not using the LM helper that we saw earlier because we want to be able to make sure that the first value is okay. The errors that this program throws are going to be terrible, but that's fine. It's a toy language, really. So the second argument is prog, and then we have 1, 2, 3, and 4 underscores. They say we don't care what that value is, just throw it away, because we're not going to use it. So this will only work if the first element returned is OK, the atom OK, and the second is a variable prog that gets assigned to whatever the second element returned from Lisp parse program is. I'm going to jump ahead a little bit here, and because I know that program is a Lisp. Goodness, program is a list of evaluated parsed values. We're going to want to evaluate all of them. So knowing that, I'm going to write this the next bit of code just so because everything that our evaluator needs to do is covered by these few lines of code. So it seems silly to wait until later when we know what's coming. So I'm just calling reduce. We're going to see this kind of pattern of two values in a tuple a lot during this kind of file in our evaluator. The first element here, we're starting with nil, is the value of our program. And the second is what we call our environment. That is effectively a mapping of variable names to variable values. That's what tells us what we currently have access to. And say someone tries to get something out of there, which we haven't already defined, that's when you get a variable not defined error. That is the core of everything we're doing here. This is the initial value for the reduce. So if the program ends up just being an empty list, then the value will be nil. You see we're pulling out the value here, and that's what's going to get returned at the end. And then finally, I think that's our program parse program line, and then we're going to do a language which only returns the last thing it evaluated, so you can kind of do things in order for side effects. We therefore will throw away any intermediate steps, and this function is dealing with all the intermediate steps. And then we're just going to return eval p e, the environment. So this eval function, I know we have a function eval here. This is a different eval function which we haven't defined yet. That's okay. If we try and run it, it will break. This is going to be kind of where our pattern matching comes in. So each clause that we define for eval will kind of handle one type of value, and that will help us kind of scale our software. This is from some playing around, this is quite a nice evaluator to expand, because you'll see, but each eval only deals with one thing at a time and then passes it on to another eval. So there's a lot of recursion going on, but you only need to think about one thing at a time. And at least for me, that helps a lot. Just format that, and we'll implement our first kind of 2-argument eval. Elixir counts the number of arguments or the number of parameters when defining functions, and that's how it helps. That's how it identifies functions. So public eval with 1 argument is different from private eval with 2 arguments. It just doesn't even consider them similar, even though they have the same name. And of course, you could name them something different, but I didn't have enough imagination to do that, I'm afraid. So this is a pattern matching guard. So it says this function body should only be called when the num argument is a number. And we can just return the number back because number evaluates to itself. Will that work now? Let's test it. That's probably the best way of seeing if it will work. It does. So now we're at a stage where we can evaluate the number 5 and have it return 5. we should already be able to do the second step, 54.2, and it outputs 54.2. So we're in a good place. We're already evaluating numbers and returning them. It only took about 20 minutes. Sweet. I think the next step won't work yet, but we'll try to see what happens. 543 should result in 3. It's actually outputting 5. We will look at the parser to see why that might be. If I could type program 543. Okay, so we're seeing it's getting a little lost at space, which we've already seen, but it was easy to forget. And so it thinks that the entire program is done because it doesn't know what to do with space. The reason, so parser combinators have a difference between a failed parse and an incomplete parse. If it wouldn't have started with something that counted as a number, it just wouldn't have matched and it would have been a problem. So we see here there's an error, expected ASCII character in the range 0 to 9, because that's what it thinks a number is. So it cares about the first thing it comes across. After that, once the parse stops working, once it stops being able to process things successfully, it just throws the rest away. It doesn't care. So that's one interesting thing about parser combinators, which we're kind of like using to our advantage as we're gluing things together. So heading back to the parser, so we can see like we don't actually kind of take into account that empty spaces can exist. This is an easy fix. We're actually going to just say change that to term and have one parser which tells us what all the possible terms are, i.e. all the possible individual pieces that go together to make up a full program. In this case, we're having a number. It's because I was typing without looking at what I was typing. We're also going to ignore empty spaces. So ignore basically consumes it, but doesn't add it to the output. And we're going to do the same thing for new lines. We're then going to define a program, which hopefully I think we're going to continuously add things to term, but we should only ever need repeat parsec term for the program. This basically says a program is a collection of terms, like any number of collection of terms. Again, the parsec :term thing is just to make sure it works with at compile time rather than at runtime, because parsec uses nimble parsec uses macros. Excuse me. So now that is done, we should be able to eval for, it doesn't really matter what numbers we use, but we should be able to eval the next few and even to the point of adding in new lines, and it'll return the last evaluated thing, which is exactly how we want the language to work. So that's good. After that point, things start to get a little more interesting. So the next thing we're going to need is define. So the define keyword's going to be a special kind of symbol, which when you have define and then a variable name and then a value, the variable name will become associated with that value. This is going to be a few steps, as you might imagine, because like we don't even have symbols yet. So we're going to start by parsing again. We're going to parse symbols. Sorry. So we're going to start by defining what valid characters for a symbol are. This is actually like a poor name because it's going to be able to consume a whole symbol, but it's just going to output the same string again. Whereas we want to kind of add a little wrapper around that so we know it's a symbol. But for now, we'll call it symbol characters. I'm going to have to read off my list for this one because we're going to define symbols in terms of what they can't be, just because it's easier. In a more full language, you might want to kind of more rigorously define what a symbol can be. So symbols, I've realized I've just been saying symbols without saying what symbols are. So a symbol is just going to be something that stands for something, whether that's a variable name, a keyword, eventually quoted symbols, or atoms. Like they're just like something that can mean something else. It's going to effectively be just a string, not a string. I'm sorry. It's going to be, in the terms we're talking about, a string, but in programming terms, it's going to be like say a variable name or something. So we're going to start with the mysterious not 32. That's saying a symbol can't include a space character, although we ignore it later. If a symbol gets defined before the ignoring of space, it'll think space is part of being a symbol. We don't want that. These are like ASCII values. Also characters. These little question mark things that we've used before are characters. So we don't want to use parentheses in our symbol names for the simple reason that we'll be using them for lists. We need not colon. We're going to use those if we want get around to adding atoms later on, which we're going to need for interop with Elixir. Not 0 to 9. Funnily enough, we don't want numbers because that could be confusing. Again, if you were doing this like not a non-toy language, you might want like the first character to not have numbers, but everything else be fine. We're not going to do that here. We're just going to say the whole string can't have numbers because it's simpler. And finally, we don't want a dot, a point to be in our symbols, min 1. So that says that it has to be at least one character. And again, if we Elixir format that, and then add. So we're going to take our symbol characters and pipe them through. We've not written this yet, but we're going to pipe it through a function called wrap symbol. And again, this is just going to wrap it up in a tuple where the first element is the keyword symbol, just so we always know what our symbols are. Right now, you could, with the language as it is, you could just say that a bare string after it's been passed is a symbol, but we might want to do something else with those later. We might want to implement strings that just use Elixir strings. So this is kind of like my attempt at not painting myself into a corner. So that then becomes the thing we add into term. So we've now said that one of the terms of our language can be a symbol. If we recompile, we're going to again have to go to the program, go to the parser here. So if we just say hello, then we get the symbol hello. You'll notice some odd syntax here. where we're kind of getting, these are called keyword lists. So this in Elixir is actually equivalent. Equivalent to this. I can't type. There we go. Equivalent to this. So if you input, like, if you have a list of tuples where the first element is a symbol and the second element something else, they'll kind of pretty print to kind of like a symbol with the colon, the keyword with the colon at the end and followed by the value. And you can write them like that as well, and they're interchangeable. They're the same thing. So yeah, we can see we can have multiple symbols in a row. What we can't do yet, funnily enough, which is the next step, is lists, which we're going to need. So what do we do? We need to define x as 4. And as you see, it doesn't even start parsing because it doesn't know what to do. So we're going to say, so we're going to do a list first. Tell you what, we'll call it open list. So open list is an opening parentheses, closing list is a close parentheses. So these are the literal characters we want to define the start and end of our list. And then we say a list is, we ignore open list. So that means it has to be there, but we don't care. We don't care about it. It doesn't matter to us. We can have empty lists, so we want it to be optional, and then we can have any number of things inside of our list, so we want it to repeat. We get recursive because a list can actually contain any term, including list. So we just say we repeat a term, and then it has to end with a closed list. So if we add list into our collection of terms and recompile, we now get symbol define symbol x 4. Nice. The eagle-eyed among you may notice that this isn't inside a list, which is a problem. This is just flat inside the main like program list. I think we can kind of demonstrate that better by having define y5 afterwards, and we just get this like onslaught of everything together. As this is going to be a Lisp, we're really going to need like the lists to provide some structure. And they really do need to kind of map to lists under the hood, which is going to map them to Elixir lists. So we're basically going to have to kind of squeeze everything there into a list. Luckily, Elixir has enum into, I think it's called. Hang on, let me check. Yep, enum into, and then we're going to say the second argument to this, which is what goes into this third array, is going to be the empty list, and that's just going to say it's going to take the list of things it's just passed as a single list. That's important, not the whole lot, just the single list, and squeeze it into a list. And then I'm hoping that will now, so now we've got our two lists. We've got define x4, define y5. We will see that doesn't evaluate yet, which will be the next step. So what it's telling us there is that there's no there's no clause for the eval function that can take a symbol called define. It's saying that like we tried that attempted clauses function showing 1 out of 1. So it tried to pass it into eval num when it's number num, but symbol define that list under number 1 isn't a number, so it won't work. Which kind of gives us a hint as to what we need. We need something that's going to take the symbol, a symbol with the word define. Again, this symbol here, where this isn't a this is a special keyword we're making define. So we can write a specific eval rule that handles it. This isn't going to be like how we handle all of our symbols, just the define keyword, and possibly some others later on, depending on how far we get. So we're going to use pattern matching here. So we can see that we've got a list, and the first argument of that list is a tuple, which takes symbol and the literal string define. So long as we fit into this pattern, this will call. And then we're going to use the pipe to say, okay, everything on the left of this pattern is the head of the list, then just shove everything else into the rest argument. So that will kind of give us a list with symbol x 4.0 in this case. But more generally, it'll give us everything in that rest value. And then, so what do we want to happen? We want the first value in that rest, in which case, in this case, the symbol x. We want that to be associated with the second value in the rest case, in this case, number 4 in the environment. So we're going to extend the environment to include that. So this is us defining a variable. So we're going to take, again, using pattern matching, we want symbol name and we want the body. Sorry, I nearly put value there, but it's not yet. Equals rest. So this is just going to split rest up into 2 values. We're not using the resting again because we're assuming that this list is 2 values, and if it's any more or any less, we do want it to throw, because it should be exactly 2 values for the define keyword. Again, error message is going to be awful. That's just going to have to be okay with us for now. And then we're going to eval the body. The reason being we're going to want to make sure that we can pass in like function calls. Anything else needs to be able to pass into the body. This is a simple number, which has already been evaluated, but that's not necessarily the case at this point. So we're going to want to evaluate it. Just because numbers evaluate themselves, so they're like the simplest case. That's not always true. And then we want to extend the environment. So we're going to kind of clobber the env name. We've already clobbered it once here, but we're going to clobber it again. And I think it's map dot put. So we're going to put into the env map the name val, and then we're going to return val env. So this env has had the name and value pair put into it, and that's what we're returning. So that's effectively how you define a new variable. Along with this, we're going to need how do we evaluate variables by themselves. This is going to be the opposite. We're going to, well, not exactly the opposite. We're not going to remove the association, but we're going to look up that association. So again, as is common, we're going to use, let's just click sim. We're going to go with symbol sim using pattern matching. We only want to evaluate this if it's the only thing. Let me just double check that. Yeah. So we want to evaluate a symbol by itself. It doesn't have to be in a list. So this will evaluate. This will be evaluated when we've just got a symbol sitting by itself. And what we want to return is the what is contained inside that symbol. So inside the environment. So we want env sim. So this is a map lookup. There are functions to do it as well, but they're effectively the same. Again, if there's nothing there, we're going to get a terrible error message that won't really explain much from the user's point of view. But for our purposes, that should do. Note, it doesn't actually matter right now, but note that I've put this eval at the bottom. If we wanted to, say, evaluate something with a specific symbol there, and that specific symbol was after this function call, it'd never get hit because it pattern matches in order from top to bottom. So if there's a more general case before a more specific case, the more specific case won't ever get hit because the more general case will cover it. Again, we're not actually using that right now. It doesn't matter, but it's just kind of a habit to get into when you're writing pattern matching cases. I wonder if this will work now. That's because I put Lisp. So if we try to define x as 5 and then just evaluate out x, we get nil. So it's not working. That's good. So we must be missing something. Just let me parse it out just to make sure that it's parsing correctly. So we're getting symbol defined, symbol x5, and then symbol x. So I'm going to io.inspect env at this point and just check that I'm getting the correct thing. Just checking that is passing in the environment there. Yep, and it's passing in p. Again, the exciting live coding experience. Oh, it works this time. Oh, did I not recompile? Is that why? No, I did recompile. Interesting. Is it when I put a? Is it when I put a? Ah, I may have broken my own language there. That's fun. Tell you what, I'll move on now because it seems to work when it's all on one line. And if we have time at the end, it might be because that's evaluating out. But if we have time at the end, or if it breaks, then I'm going to go deeper into that. But unless that's the case, I'm going to try and ignore that because I don't understand what's going on off the top of my head. Oh, I'm going to keep on looking for this now. So I name file. Sim. Huh. Sorry, that's thrown me off a little bit. The next thing we're going to need is the ability to define lambdas. This is where, after we manage to do this, the language kind of becomes Turing complete in the fact that you can like emulate lambda calculus with it. The language wouldn't be particularly pleasant to use, but technically once we get to the point where we kind of like functions passed into functions and evaluating, we actually didn't need the numbers, we didn't need the define, we just needed the functions. But I thought this was a more interesting path. This is going to be interesting, and hopefully the issue we're seeing now won't come back to bite me, and I won't have to like dig into that too much more. But yeah, this is going to be where it gets interesting.
I was just wondering, is that because you know how to handle space, but you haven't handled new line? So you're not handling all kinds of white space.
We should be handling new lines here. We're passing them out correctly.
Okay.
It's just not evaluating correctly. Oh dear, I've managed to get into a rather odd case there. Let me just double check again that it is passing correctly, but I'm fairly sure it was define x5 4. It doesn't really matter, and then new line x. So we're not repeating, so it thinks it's lots of new lines x. Tell you what, I think if I move symbol to the end, that might go away. The reason that is define x for new line x. Yes. Okay. So the reason that was is because I forgot to put in that new line isn't part of a symbol, so it was thinking that the new line itself was part of the symbol name. I'd forgotten to take that into account. Sweet. It's funny that I'd never run into that while practicing, because I've done this a bunch of times and never seen that problem before. But I guess live coding will always bring those things out. Let's try that again. There we go. Okay, problem fix. Good. That makes this next part a little less terrifying, because we're back on my practice route now. Okay, so this is going to take kind of 2 steps. So first we're going to need to be able to define a lambda, define a function, and then we're going to need to do lambda application. So that's going to look like left lambda. So we're going to have like, let's say the identity function. So this just x in the brackets. The first is the arguments, and then the rest is the body. Anything that you pass in is going to pass it straight back out again. So something like lambda xx, left lambda xx4 should output 4. That's obviously not going to work. We knew that. But so this part is the definition of the lambda that we're going to want to do first. And this like kind of outer is the lambda is the first thing in the list, and 4 is the second thing in the list, and it's going to take that 4 and call the lambda with that 4 as an argument. So the first thing in a list should be considered to be a function unless it's a special word like define or lambda. So what we would expect to see for something like just a straight up lambda by itself, we'd expect instead of an error to see that we had a Elixir function, because we're just going to use the underlying Elixir function to represent our functions. for the simple reason that it means we don't have to try and come up with a way of encoding functions. Elixir does it for us. So this is going to follow the same pattern as define. Want a list that starts with the symbol lambda, and then we want the rest. Then we want the env, and we're going to. I'm probably going to refer to my notes more in this part because it's easier to get lost. So we want the so the rest here is the lambda itself. We have the arg names, which is, let's get this up here. The arg names is this bit, and then the body is everything else. The reason this has got an extra list around it is because adding something into the rest wraps it into an extra list, so we'd end up with a list of a list, and that's not necessary. So we're just throwing that away. Given that, so the pattern we've been following all along is the first thing we return is a value. The second thing is the environment. Defining a lambda doesn't actually affect the environment because it doesn't add any names to the space, to the environment. It isn't like defining something. It's just an anonymous function at this point, so it doesn't have a name, and therefore it's not in the environment. The environment is for names only. So we can kind of do the second value of this easily. We're just passing in env. As I mentioned, we're going to use Elixir functions to be more precise, Elixir anonymous functions are slightly different to represent our lambda. So the first argument is going to be a function. Hopefully that makes sense. And then how we're going to kind of represent this is, oh, I've messed up formatting somewhere along the way. Makes format failed file. Oh, it's because I've had an empty function and that's not allowed. Oh, apparently that's still failing. Is that why? It doesn't really matter. We can just continue writing, but there we go. So we're going to accept the values to this function. So what's going to happen when we apply is the arguments are going to be evaluated, and then the values are going to be passed into the function. And then what we need to do inside this function, we have the argument names from the part in the brackets after lambda, and we're going to like mash the argument names together with the argument values. So we have a list of argument names to values. Then we're going to, inside the function only, we're going to extend the environment with those pairs. And then we're going to evaluate the body using that environment. So that's effectively going to be how functions work. Hopefully that makes sense. If not, it might make more sense once we kind of actually implement this. But it's going to, yeah, the evaluation works exactly the same as everything else, but we're kind of, we're taking values from somewhere else and using them here. This, incidentally, is how we implement our scope. So the inside of a function is kind of the only scoping rule we have at the moment, and that says that if something's defined using the define keyword, it's effectively global. If something is defined using the function arguments, like a name like X is defined using the function arguments only, then it's only available within that function. If there's something called X outside of the function, then so Elixir values are immutable. So this environment that we're going to construct will only exist inside that function. So anything called x outside globally will be overridden inside the function if the argument's got the same name. But then outside the function afterwards, that won't be affected. And we don't have to do that like ourselves. That's just handled by the fact that Elixir uses immutable values. Doing it the other way would be harder, where globals get overwritten inside functions. So that's another reason that Elixir was quite a good choice for this. Names. So first we want the arg names taken out of the symbols, because you know they're like each of them are wrapped inside this like thing with the tag symbol. So we're gonna enum.map over them. I'm gonna take the symbol. I guess that's name is a better name, and let's just return that. And we should have now a list of strings, which are just the names of the argument. And then we're going to take the args. We're going to make the args by doing enum zip. And we're going to do arg names, arg values. So now we're going to have a list of tuples, pairs with arg name, arg value, which we're then going to use to construct our env using enum.reduce. So our initial value for our environment is our current environment. And then we're going to take symbol name. Is that right? Wait, no. Key value. I was like looking at up here and being like, I'm just repeating that. I'm just going to repeat that. That was wrong. I'm going to take that key value and the environment, and we're going to do map.put the environment key value, and here that's env, not eng. And then we're going to eval the body, the env, and we normally are returning these tuples, but this is a function call, so we just want to return the value. We don't care about the environment. The environment just gets thrown away afterwards because the function's ended and the environment was function specific. So we're just going to return the 0th element again. Whew. So that should be lambdas. We still need to do calling a lambda, but you can see now we're getting a function back when we pass in a lambda. So let's do application. So what does this look like? This looks like we've got a list we're evaluating, and we expect the function to be the first argument, the first element in the list, and we expect the args to be everything else. We do need an environment. And then, so what we want to do is we want to evaluate both parts. So we want to evaluate the function. So we have a function instead of an AST. And we want to evaluate all of the arguments because we want those values. And then we're going to pass the arguments into the function to get the value. To kind of take to use the function we've just defined, or we've just constructed, I should say. So again, we're gonna like clobber this function by evaluating it, and then we're going to take the arguments, and we're going to again map over them. Just by evaluating them. Yep. and taking the 0th element. We don't care about any arguments that anything that kind of expands here. We're only expecting our define thing to be on the top level. So again, just briefly, I've just noticed that I might not have explained this. Here, this is purely symbolic now. We're not asking for any literal symbol characters. We're not asking for anything else. So this will take any list that hasn't already been kind of dealt with and assume that the head of the list, the first thing in that list, is going to be a function. We're just assuming that this will crash out if that's not the case, but that's what we want, because Lisps tend to assume that the first thing is a function. We may get around to adding quoting, in which case that will get caught before this, and what we return won't be. We'll assume it's a list and not a function, but we're not there yet. So we're going to call that function with args and return the environment. This odd syntax with a dot here, like I think I briefly mentioned, Elixir treats anonymous functions slightly differently from kind of ones defined in a module. I'm not entirely sure on the design decision behind that, but the only practical thing you have to be aware of is you need to put a dot in before you call it. No idea why they chose that syntax or why they chose to enforce it at all, but they did. It was very purposeful, I'm told. I'm just not sure why. So if you do know why, then feel free to write an essay in the Discord channel. But just trust me, that's a function call for an anonymous function. So now I'm hoping that we've kind of reached full Turing complete level where we can kind of do church encoding if we wanted to. We're not going to. I'm not going to get into that. But this should kind of cover everything. And ta-da, we've got to the point where we can just pass that in. What did I think I did a slightly longer winded version of that. Yes, we're Turing complete. And it only took an hour and 12 minutes. That's not too bad. So we're going to define the identity function here. And then we're going to ID5. This is exactly the same as above, but it's just to kind of demonstrate that all of our pieces work together. You can even do pass in identity to identity and then call that with 5. So these are fully working functions. There's no magic going on. This is how functions work. That everything's sorted. We obviously only have numbers and no operators, so you can't really do much unless you really want to get into say your kind of untitled lambda calculus stuff. So you could do all of that, but anything else is going to be tedious. So we should now. We've now reached the little bit in my document where I explained that anything after this is a luxury, and that this is the equivalent of people saying that everything should be programmed in assembly. Everything should just be lambda calculus. Really, I don't think there's any need for any more. You don't actually need it, do you? It's all just unnecessary. So here we go. If we do a list of 1, 2, 3, expected a function, got 1. So what we want to be able to do Tell you what, at this point, I'll ask if there are any questions explicitly. I know I said that please throw them in, but I don't think I've got any. I'll keep typing, but if I've gone too fast or you want to like zoom in on something, feel free to ask now, and we'll see if there's anything else.
So we had one sort of not quite a question, but a comment about Lisp flavored Erlang. And I wanted to come back to, I think I heard you earlier mention that you found Elixir was a really good fit for this kind of work. And so I wondered if you had any thoughts about, well, Lisp flavored Erlang being a dialect of Erlang with a sort of Lisp syntax, and in general about what it's like implementing a Lisp in particular in Elixir or Erlang or similar languages.
Yeah, I actually haven't played that much with Lisp flavored Erlang, which seems wild considering I'm implementing a Lisp in Elixir. But from what I've seen, it looks pretty good. I think the interesting thing there is kind of where I was going with this language, and I did know about it, and I don't know why I've not looked too much into it, but the idea that you can like leverage the kind of Beam, the Elixir, Erlang, other languages kind of ecosystem in the same way that Clojure does with the JVM is like kind of fascinating to me. And so that's why I wanted to like play around with it myself before I got to before I kind of narrowed my vision by looking at another implementation of a Lisp in like near Erlang, if that makes sense. I didn't want to like become distracted by something that already exists and forget about some of the ideas I had for this. What we've seen here is obviously a very, very simple Lisp, but I'm hoping that I can develop this into something where it kind of it's a more Lispy environment with hopefully a proper REPL where you can like when you make an error, it actually just stops execution and tells you like here's what's defined in the environment. Do you want to like edit any of that? Maybe that's why there's an error. This function's not defined. Maybe you want to define it. That kind of stuff is what I would like to get to. That's where I want to play around in. And I didn't really want to like spoil myself from playing with any of that by looking at how someone else had implemented it. Which is that's basically why I've not really looked into that. In terms of implementing a Lisp in Elixir specifically, I don't know if anyone's seen, I think there's a video on YouTube called the most beautiful, I think it's called the most beautiful code in the world or the most beautiful program in the world. I'll try and find a link, and like I can't do it right now obviously, but I'll try and find a link and put it in the Discord later. But that's kind of it's an evaluator of Lisp and is very heavily influenced this evaluator. That's written in Scheme. This obviously isn't in Scheme, but it uses the same kind of pattern matching features. And yeah, just when I saw that and I was playing with Elixir already, and I really enjoyed the ecosystem and the fact that you've got this like really kind of interesting Beam system in the background, kind of handling concurrency and parallelism in the like across everything. It's like it'd be cool if you could kind of play with some of those like really low level Lispy like abstract ideas with the ability to just like have access to that really broad ecosystem and really weird kind of parallel and concurrent way of thinking. So yeah, that's why I was playing around with it in Elixir, because I was playing with Elixir anyway and saw someone define a Lisp in Scheme.
Brilliant. So you mentioned some of the features that you would like to look at in future. We've had a question come in on the YouTube channel from James asking, how hard do you think it would be to add a macro system?
It's something that I've been thinking about actually, and I'm still not 100% sure. I was going to first kind of play around with adding a macro system in using like implementing one in Lisp, just because it feels like that would be a good way of like getting my head into the right kind of space. As I'll post the kind of full source code up to this as well. And you'll find that in the full version, I've implemented quoting and unquoting, which is kind of the first step to a macro system, I think. And that is surprisingly easy. So I'm hoping that it's not that difficult. I think after I've written a printer, I think a macro system was my next stop.
Great.
Because that would be interesting.
Yeah, so maybe you can come back later in the year and show us your macro system.
Yeah, writing your own macro system.
That'd be great. So everyone, as you can see, if you can ask any questions in YouTube, then I'll pop up and post those to Sam later on. But yeah, if you want to, there's a thumbs up from Jashek as well, who asked about LFE earlier, and onwards.
Nice. I don't know how long we want to have this take, but I'll try and do quoting at least very quickly. So we want quote list 1, 2, 3 to just return the list 1, 2, 3. So we want the quote effectively to kind of block any evaluation. For now, we're going to say that we're going to get rid of the sugar and say quote 1, 2, 3 is the same as the actual quote symbol, just so I can do it entirely in the evaluator. Adding the sugar is relatively simple afterwards. You go into the parser, you look for the quote symbol, and you effectively transform it into the AST for the full version. So we need to head up here to do this. Just get my crib sheet because otherwise I'm scared that I'll do it wrong and you'll all laugh at me. Symbol quote. So what we're effectively saying when we quote something is we want it to go unevaluated. We also have this concept of unquoting, which I'm going to implement in one fell swoop, just to avoid having to kind of come back later, as it's just a few lines of code. So we're going to use this really interesting thing that Elixir has, which are effectively anonymous functions with multiple bodies, and this is just like a shorthand for being able to do pattern matching within within function arguments, parameters. Symbol unquote. So when we unquote something, we're stating that in actual fact we do want this to be evaluated. We said we wanted the whole quoted mass to remain unevaluated, but the one part we've unquoted, we'd quite like that to be evaluated. This, if you check out the document I posted at the start, right at the bottom, you'll see when we're doing foreign function calls to Elixir, you actually need the ability to quote in order to pass in lists. And if you don't have unquote, then you can't pass in values that you've calculated in the language. So like quote unquote is quite vital once you get to that kind of necessary stuff. So our unquote is just doing the normal thing that our evaluator has been doing all along. We evaluate the body and return it. And if it's not unquoted, then we just return the thing itself. So that's the AST completely unevaluated, exactly as it should be, if it's been unquoted. If it's been quoted, sorry. And then I think that's everything. Oh, compilation problem. What part did I miss? So we've got rest in the map rest. We've got a function. What's it complaining with? Syntax out before eval. Oh, I didn't add in equals. Sometimes you're looking for things that are more complicated than they actually are. So if we do Lixp.eval, let's say we'll define x as 5, and then we'll have quote, and we'll have x unquote x. I think that's right. And we'll get. Oh no, that didn't work. Oh well. Well, quote worked, so that's something. You see, we got the list of symbols directly back. I wonder why unquote didn't work. Oh, I know. I left that wrapped in an extra list, and so it didn't actually process the inner body. Recompile, define x as 5, and we're going to quote, and then we're going to do 1, 2, 3, 4, unquote x. Ta-da! That's probably where I'm going to leave it at for today. Like I say, I'll post up the kind of full source code after this. That includes, I think the only thing extra that we've got there is atoms and the foreign function interface. So I'm just going to say that I'm leaving that as an exercise. And you can peek at my source code if you want a hint.
That's great. So if anybody has any particular questions about foreign function interfaces or anything else, then obviously please do ask now on YouTube. Or Sam, did you say you're going to be available on our Discord server
Yes.
for a little bit after this?
Yeah.
So if anyone's not on the Discord server, that is the invite code. There's also links from the YouTube and Eventbrite pages about that. And we will post the info that you, additional info that you send us, Sam, on Discord and on the YouTube page as well later.
Sweet. Sounds good.
So thank you very much for that. That was very interesting, and it's amazing how quickly you get to having a basically functional, like, that Turing complete moment is quite something, isn't it?
Yeah, it kind of, the first time I did it, it amazed me because it takes like 45 minutes to get the basics out of the way, to get the structure out of the way, and then within 10 minutes you've got it Turing complete, and it's just like, well, that last part was really fast. How did that happen? Yeah, it's a wonderful bit of code. Like I say, I will post the YouTube video that kind of inspired it, because it's quite the rabbit hole if you're if you're interested in that kind of thing.
And so again, just one question while we wait to see if anyone on the stream has any kind of final questions. Have you ever attempted to implement a language before using some other technology, or?
No, not a programming language. I've done like small kind of parsing projects before, where I've needed to parse out like an interesting one was an email address, for example. But I've never then gone on and done an evaluator for anything. So I think the last parser I wrote that wasn't for a language was for Git commit messages. For example, at work we have an automatic versioning system that looks at your Git commit message, looks for keywords, and versions the code based on what the keywords are. So I've done some parsing before, but yeah, never a full language, like I say.
Great. I think that's really inspiring that that something like that video and a functional programming language with a good parsing library, you can get this much done so quickly.
Yeah, it took an afternoon of like I said with macros, like I started in Lisp and like kind of basically just copied along and then did it by myself blind in Lisp, and then I was like, right, I think I can do these same concepts in Elixir, and spent a couple of days doing that, and then yeah, it was done. It's nice.
That's great. So no questions come in. Thank you there from Hassan, and thank you from all of us at Lambda Lounge. Again, everyone, if you want to join us on Discord, we'll be there for a little bit today, and we're there generally. If anyone is interested in talking at Lambda Lounge in future, please do get in touch with us on Discord or look us up on the internet, and we'd love to host interesting talks about computer science and related topics. So thanks again, Sam, and
no worries.
Good night, everyone.
Night, everyone.